Good morning, everyone, and welcome to the DEX MRO Expo 2021. Thank you for joining us today. I am Mario Sawinski, editor of MRO Magazine.
And I'm Mike McLeod, editor of Design Engineering Magazine, and together Mario and I will be emceeing today's event.
We have two exceptional keynotes today, and one of which will start in a few minutes, looking at the collection and value of machine-generated data. The afternoon keynote, starting at 1 p.m. Eastern Time, will discuss commercialization, the too often overlooked, and dark side of innovation.
In addition, we have a number of sessions divided into an MRO stream and a design engineering stream. MRO session topics will explore how effective asset management starts with good assets, scheduling and planning, as well as bearing lubrication and health insights made simple. Design engineering session topics focus on practical AI for manufacturing and simple tools for engineers in a fast-paced market.
Before we begin, we wanted to thank our sponsors, without whom this event would not be possible. Our platinum sponsor is Creaform. Our gold sponsors are SKF, More Electronic Inc., and Deb by SC Johnson. We wish we could all get together in the same place, but since that's out this year, we have come up with an expo that is as close to an in-person event as possible. During the proceedings, be sure to take advantage of the networking tab, chat boxes, and exhibitor hall, so you can communicate with the other attendees here today and move the 20 exhibitors and more than 20 exhibitors waiting for your questions all day.
To facilitate that interaction, we've placed networking breaks throughout the day and after the event for attendees to visit the exhibit hall and find out what the exhibitors have to offer. So with all that out of the way, please sit back, relax, and enjoy the first ever virtual MRO DEX Expo. The first keynote presentation is by Steve Loftus, who will speak about the collection and value of machine-generated data. Take it away, Steve.
Okay, can you hear me there? Nope. Somehow. Okay.
All right. I'll just do a quick introduction for Steve, and then we'll get going. Steve Loftus is the president and one of the founding partners of Innovative Automotion of Barrie, Ontario. It has grown from just 55 employees in 2014 to the current 145 full-time employees, and a new 88,000 square foot manufacturing facility. He spent close to 8 years working in industrial maintenance before going into his 35-year career in custom machine manufacturing, industrial automation world. Steve has maintained a belief in building machines that add value based on reduced maintenance costs. He believes that with the introduction of Industry 4.0, there is an opportunity to continue to add value by automating the collection of data. Steve will now present his keynote on the collection and value of machine-generated data. The presentation will explore the methods of collection and storage of data and analyze what value the data can create. It will also look at non-traditional data and what value it can create for your operation by improving manufacturing processes and reducing production overhead costs. As well, Steve will look at creating user interfaces to apply the information that has been collected to more logical value-added decisions. Over to you, Steve.
Thank you, Mario. And first of all, I would like to, just going to share my screen here. Oh. I've lost my ability here. Just give me a sec. I can't. There we go. Okay, so you should have a screen there. So we're going to talk today a little bit about collection of data and the value of the data that we're actually collecting and utilizing that. Okay, and the value in collecting that data and having the machine do some analyzation of that data. But first of all, I'd like to thank the fine team at the MRO and the Design Engineering Magazine for allowing me to do this presentation. Okay, is my screen shared? Okay, so let's talk a little bit about what are the methods of collecting that data. So what are the devices we're going to use to collect the data from our industrial platform, our shop floor, and move it into a system where we can do some analyzing of that data and then feed information back to the machine itself or to outside sources that are going to allow us to make improvements in a process. And the next point is, what is the impact on the data based on the collection method? So are we limiting ourselves in what we can do with the data based on how we're collecting it? The other thing is, what is the impact of the usage of the information on the collection method? So if we're using it in a certain way, is there things that we need to explore prior to starting this process so we make sure that we're collecting in the proper method? So one of the base things here we need to do is think through the whole process to make sure that we're building a structure that's going to support everything that we're trying to accomplish. So we're going to talk about collection first. So within the collection, I've identified 4 key areas that we need to address. They include the methods we're going to collect the data, the sources of the data, where we get the information from, how we're going to store it, and then in the end, what improvements can we make to those processes. Okay, now the screen froze. So the methods. So we're going to talk a little bit about the methods that we're going to collect that we're going to use to collect that data. So traditionally, we've done certain things, but now we're moving towards the OPC platform, which is an open platform of communication, which is a predefined set of standards to move information from the industrial devices, the PLCs, the HMIs that are on the shop floor into a Microsoft-based platform, allowing us to analyze that data and take that data and create some value from it. The other option is, so the first thing we talked about is a server, so an independent device that we're moving the information via to our Microsoft base. The other thing that we're talking about is the OPC, the Open Platform Communications that are embedded into the device. Now there is some limited number of devices that are OC or OPC enabled or embedded. But there are more and more of those devices becoming available, which removes one of the steps in the process. So we're moving our data right from our device directly into our Microsoft-based analytics software. And then there is what I would call one of the more traditional systems, and something that Innovative has done quite a bit in our earlier days, which was an open structure or a custom software. So we would write custom code that would actually, we would move the information from our PLCs into this custom software that we would generate, and then use that software to move it onto our Microsoft-based storage and analyzing softwares. So some of the sources, where are we going to get this data from, and what are we collecting? So one of the things about the sources is we need to kind of think early on in our process, what is going to actually give us value. So we need to make sure that we're not over collecting data that's going to create no value add, but we need to collect critical data that's going to actually improve our processes. So from within the sources, there's physical measurement. So physical measurement are things like force and displacement, speed, whether it's RPM or on a linear motion, feet per minute or meters per second type thing. And then there's things such as power. If I'm, have a motor or an actuator that's moving something, I may need to collect voltage or current or resistance to do some analyzing of the value that product is going to produce or whatever it's going to manufacture. So then we have some newer technologies in vision inspection. So one of the things with vision inspection, they can do things, some of the things that we've traditionally done with the physical measurement, such as displacement or measurements, but they can also do things like shading, so they can look at shades for looking at surface defects, or a lot of component manufacturers now, if they have, let's say, molded gears, they're molding them in different colors based on the actual product, so that when they're doing their assembly process, it becomes very easy to detect if someone's put the wrong component into the assembly. These types of decisions earlier on in my product design can actually allow me to increase my throughput, because I'm not building defective components or components that require rework. And then one of them, the most obvious, is missing components. So if we have small assemblies and there are key critical components that must be built in a certain order, we can use vision to ensure that those things have been placed and placed properly. Okay. And then the one of the things that we have traditionally always done is the functional test at the end of the line. So some of those other measurement sources may be in process, but the functional test is typically at the end of a sub-assembly or an assembly process, where we're looking to make sure that all the components, even though they're within tolerance, that stacked up tolerance is allowing to function correctly, whether it's an effort to actually move an actuator, or if it's a travel limit based on a movement. We just want to make sure that the thing functions correctly. So those physical, those function tests will actually prove to us that our product is within tolerance. The next thing we're going to talk about is the storage. Where are we going to put this data? Like we've collected it. Now, where are we going to move it to? So we got to move it into a database. So these are some of the things that we need to be strategic about when we're planning, because a lot of this has to do with the planning to make it efficient. How we're going to move this into the database to make sure that we're efficient in the use of the data, we're efficient in the retrieval of that data. So we don't want to build a database that it takes us 5-6 seconds to retrieve data that I need every 20 milliseconds. It just doesn't work. So we need to be strategic about how we store it and how we're going to be able to retrieve it. So those are the main considerations in how we're going to move that data. So then the next thing is, where are we going to move it to? So cloud is very very common process nowadays, but there are pros and cons to moving product to the cloud. Some of the big pluses is there's a much lower investment initially. So our initial investment in cloud service is definitely somewhat reduced based on other methods. And the skill set that I need in-house and the maintenance I need in-house to maintain that data is basically being subcontracted when you're moving it to the cloud. So the responsibilities for that are much reduced. So some of the cons include the long-term cost of cloud storage can actually be higher than other methods. And the other thing is the perceived security risk. So how secure is my data when I'm shipping it outside of my building? And then, how quickly can I retrieve it if I need it back? So the other thing is what I would call a more traditional system, which is an on-site or physical server, which is a little more traditional for a lot of companies. A lot of companies still prefer to do this. It does have a higher initial investment because now I need to buy the hardware and I need to structure it and set it up. I also need to have staff that can support it long term. So I need to make sure that I'm making that investment as well. But there are pluses. So there's the perceived higher or lower risk, I guess is the proper term. We want to reduce our risk of sabotage of that data. So if we have it internally, there's a perceived value in increased security. Whether it's real or not is entirely up to how well you protect that data. And that comes back to your on-site support people that are supporting that. The big issue on the downside is the initial cost to do this. So we have to weigh one of those versus the other and see where we're at as far as what you as a company want to do. And there's no right or wrong answer. It's what suits your needs best. So the other thing is that we're going to talk about is the improvements in processes. And what are we going to do with this data is the bottom line, and where are we going to get value from it? So what we want to really be is strategic about where we can see the value. So the more common thing is, can I improve my production throughput? So how do I adjust that? Or how do I increase that? So by detecting errors early in the process. So if I'm collecting data at each assembly process in my complete assembly of my product, I can identify errors early on, so I'm not adding value with a non-sellable good. So if I'm looking at an assembly that has 20 components, and those 20 components, I identify a product problem or a fit problem on my first or second component, I can actually set that component aside, not continue to add value through to the end of the process, and then in a function test detect that this doesn't work. So now I've added value. I probably have scrapped multiple components and I have no value in it. It's cost me money to put that thing together that I can't sell. And if I can't sell it, it actually will steal profit from multiple other components that I'm building just to offset that cost. So part of that is I'm going to be able to get more product out. I'm going to get more sellable product out. And getting more sellable product out by removing products through the assembly process, reworking early with less value add, will increase that production throughput. And then quality, and quality is one of the original drivers in the collection of data and monitoring this. So, our traditional quality checks make sure that our products function correctly, but we've now taken that steps, we're taking that further in the steps, and we're ensuring that we're building quality all the way through the process. So at each step, we want to make sure that we've added value that's sellable, and quality is one of those things that we can use to prove that. So there's two parts to the quality process, and everybody always thinks about improving the quality. But the one thing we need to really be conscious of is, from a quality perspective, if I'm, holding a really tight tolerance on a stamping, and I'm forcing the cost of that stamping to increase, but adding no value to my product, really, I'm creating a negative effect by increasing the quality. Sometimes the quality of the product or the tolerancing of that product can actually be diminished. And by diminishing that quality, I can drive my costs down on it and not have any impact on the functionality of my product, the sellability of my product. And by lowering that cost, I can increase my profit margins or reduce the product cost if I have competitive pressures and allow me to stay in the game, so to speak. So quality, you don't always have to think of quality as an improvement. You have to look at it. The quality is the quality sufficient to meet the requirements of my product and still allow me to build a functional product that has the proper life that we're trying to achieve. Okay, so quality can be used to lower our costs, and it doesn't always have to be thought as an adder to that cost. So the next thing we're going to talk about is inventory. So if we can improve our processes, our inventory, our work in process, the WIP can be reduced. So if I'm producing products and I know my incoming shipments of components is controlled better going into my process, so that means that I'm producing less rework. It means that I can actually reduce my inventory of incoming product because I'm not buying or paying for product that has no value in my process. So it means I can reduce that. And it also means if I'm able to control my outgoing, I can reduce my warehoused product. So reducing that work in process, which is really cash when you look at it from a company perspective, can I use that cash and invest it to create improvements in my process somewhere else? So just always think of inventory as cash. It's like, you got money sitting in a checking account that you need for a rainy day, but you're not really collecting any value from it. Whereas if I could take that money and invest it somewhere else and create more value for my company, there's the big plus in all of this. Rework, actually just on the inventory, the other part of that is the number of turns per year that we're going to have. If we're turning stuff over more often, the financial people will like to see that because that's part of the value proposition or the cash that they're spending on products. So turns per year is important if we can reduce that. Rework, we've talked about this quite a bit already. If I can rework product when the subassembly is 2 components versus something that has 20, it's going to reduce the amount of cost to do that, and it'll actually help move product through our line at a faster rate. So now we're going to talk about value. So this is the other half of the presentation, so to speak. The value. So within the value, we're going to talk about overhead costs and user interfaces and maintenance costs, the throughput, the quality, and the inventory. We're doing this, to collect and analyze the value, and it's not just always about the dollar value. It's sometimes about other things, such as quality, which will generate a stronger name in your selling space. So we're going to, first of all, within the value, we're going to talk about overhead costs. So warehousing. Within warehousing, everybody kind of just thinks of the space, the cost of the space, but what really is the cost of the space? Well, it's the actual floor space, but then there's all kinds of things we need to think about. It's like storage racking, it's containers, it's, the utilities, the heating, the lighting, all of that part of it. Everything right down to even tow motors or painting floor lines based on wear, or floor finishings. All of that is part of that cost of warehousing. And all of these things need to be taken into account when we're doing our analyzation and creating our value proposition. Overtime costs. So overtime really comes into play when I've got a process that I'm running, let's say 40 hours a week, and now I'm, I've got downtime of 2 hours, a couple times a week. So now I need an extra 4-hour shift to actually meet my numbers. What can I do to actually improve my throughput so that I reduce those overhead costs, overtime costs for labor? We don't want to be making up production. We should have already, produced the product. So we need to be conscious of that. So part of the thing is we want to increase the efficiency. The big part of increasing efficiency is dealing with the non-value add manufacturing, which is, the scrap components or the rework components. So user interfaces, I always throw this one in because some people don't understand the value in having the user interface, but really with the user interfaces, it's really the quick reference. So you have an operator that you're able to alert to a possible problem so that they can either deal with it quickly and efficiently or plan for the correction of it when it's optimal. So if I see something happening or trending and the operator is aware of it, something's trending in the wrong way, he can or she can look at scheduling a service person or a maintenance person to actually deal with those issues, maybe while they're on break or lunchtime, or can we do a quick fix to keep us running and keep production flowing through, and then at the end of the shift do the proper maintenance or proper repairs, or address components that are starting to come out of tolerance. So can we do some pre-screening of those things? So those are really critical within the user interface. So it's the efficiency in making decisions that allows to offset the cost of user interfaces within our data collection. And that information that's collected by operator interaction is also collected, and the system then is aware of what's going on with the machine and the operators. So maintenance costs, I look at the progression of machine maintenance from 35 years ago when I worked in that field. I worked for an employer that everything was run until it broke down, and then you stopped and repaired it. My next employer was a little more progressive in that some maintenance was preventative, but I think of maintenance nowadays, most of it should be predictive, and it should be done in advance. So it's creating minimum impact on the machinery. So what I would say here is the time to service, if it's scheduled, should be much better, because now I can have while it's scheduled, I can have my components ready, my manpower ready, my tools all ready, and then when it becomes time to make it happen, everybody's there. Where I look back 35 years ago, you would get paged, and you would pack up your tools, and you would move to a location, and then you would discover what's wrong, and then you'd go to stores to come back. Chewing up a couple hours would not be out of the question back then. Now, if we have everything queued up, ready to go, we should be able to minimize that impact. Even down to the spare parts. If I look at spare parts inventory, if we're more predictive, our spare parts can be made available as needed, as opposed to having these massive warehouses of spare components that may or may never ever get used with the company. So throughput, is the real goal in all this. We're trying to get more product out the door at a cost-effective delivery. So one of the key areas is production component delivery. So the pieces that go into the subassembly, are we able to take that data and make sure that we're pulling that product to the line as it's needed, as opposed to warehousing it or missing production because we're short shipped, those kinds of things. So if we talk about short shipments, there's one of the items that's going to have a negative impact on our uptime. So we need to kind of increase that uptime by making sure everything is ready to go when we're ready to run. Quality, and I always look at quality because that's one of the original drivers, with maintenance being the other one. So those two things, I think, were one of the original drivers in collecting this data and analyzing it to build a better product. So one of the things that at Innovative we're working towards doing is making our machines have some AI so the machine can actually do adjustments. So with the machine doing adjustments, we're able to not build quality products that don't meet our quality standards and then have to turn around and rework them or make adjustments to the machine. Let the machine do the analyzing and the adjustments based on whether it's dimensional data or inspection data or whatever. Let's get to the point where the machine is actually doing that adjustment. So prior to somebody getting a product out the end that fails in a cycle test, we're saying let the machine analyze the process and make those adjustments so that we're optimizing what we're producing. And I truly believe this will have the biggest impact going forward. The more traditional dimensional trending, we're looking at products, getting or coming close to the edge of their tolerance windows. Are they still producing quality products? And if they're not, then we need to tighten those tolerances up. Or if it's not having an impact, maybe we need to loosen those tolerances up so that we're not driving up additional costs that's not generating any value to our company. And the last item I'd like to talk about here is inventory, because inventory is really cash. And you look at even your household budget. If you've got a whole house full of items that are of no value and they're not creating any wealth for you or no payback, whether it's personal enjoyment or anything, then that inventory is of no value. You're better off having that cash value and letting it work for you to allow you to purchase other things that can create more, whatever it is that you want from life, more enjoyment, more whatever. But it's no different in a business. So if I've got money tied up in inventory that's not creating any value, I'm better off to kind of reduce that inventory value, take that cash and maybe invest it in the next data collection system on the next line to actually create more value. And this becomes the big snowball that I can take and increase my company's competitiveness to allow them to either grow or increase market share or whatever the objective of that company is. So inventory is kind of the one thing that we don't talk a lot about with the data collection and the value of analyzing that data. But the finished products that we're storing have a value, and if they're not sold, but we're storing them because that's the way our production works, then if we can reduce that, we can increase the amount of cash. And the other one is obviously, the work in process. So that's, the incoming component portion of this. And, it's no different than the outgoing components. We want to make sure that the inventory coming in is of proper quality, and it's reduced as much as possible, the same as the outgoing product, the finished product that's in our warehouse. So really those are the whole thing. So I think, kind of in wrapping up here, what I would really like to make sure that everybody takes away from this is the value is much more than what's at the machine. The value is the whole process, from the raw materials being received to the finished product going out the door. And if we're analyzing all of that, then it makes it easier to justify the spend. But we also have to be careful that we don't fall into the trap of not analyzing the process completely, because an educated decision is the best decision. So don't overstate and underachieve. You're better to understand exactly where you're at. The closer you can analyze and predict the savings for your company, the more authority you're going to have on the next project to actually to move it forward based on a successful previous project. So I'd like to thank everybody at this point for their valuable time, and hope I've added some valuable value to your thought process. I want to make sure everybody looks for the value and the cost savings, because they're everywhere. They're not just in putting a product together. It's everything from incoming receiving to outgoing shipping. And really the bottom line is make informed decisions, because that's really what will generate the best project. So on that, I would like to turn it over to Mario and see if we have any questions.
Thank you very much for the very informative presentation, Steve. It was nice to see that we have attendees from different parts of Canada, the United States, and overseas from Germany. Now let's have a look at the questions that have come in during the presentation. The first one that we got, how do we start the journey to collect the data?
Well, I think what we need to do is we need to start right at the very beginning when we're receiving components. So if you're, manufacturing your own components, you need to look at that component. Why do I have that tolerance on that component? Why am I producing it to that quality? Ask those hard questions. Analyze to make sure that I'm getting the best value I can out of my dollar spend on it. And if you're purchasing that component, that needs to be discussions with your sub-suppliers. A supplier needs to be treated as a partner. So if it's treated like a partner, you can have this bi-directional discussion and analyze whether we are getting the best possible value. So I think we need to start there. We want to look at absolutely every step of the process, and we also have to look for the pitfalls in our analyzing. Are we stating the value of something because we would like it on the machine? We have to be honest with ourselves and step that through absolutely every process, everything that touches or has any impact on the product, right through, and do a real thorough analysis. Right from the receiving door to the shipping door, to make sure that we've collected all the information necessary to make that informed decision.
Hey, thank you very much, Steve. Another question we got that came in is, how can machine learning help in this?
Well, the machine learning portion is a part that's, let's call it newer thought process, in that we can have the machines, because they're learning the process, can now take and make decisions on making adjustments, shall we say. You know, if I'm assembling or I'm extruding with a robot a gasket and I'm watching my gasket become narrower, does the machine just slow down, or do I analyze doing a repair on my head? Well, if I can slow down the robot and still meet cycle time and produce the gasket within tolerance, just have the machine do that. And then when I have a break time or a maintenance time, address the root cause of the problem.
Right, thank you again. Next question that we have, how can we get the buy-in for the investment?
Well, it's the informed decision. So when I do my cost analysis, I need to make sure that it's real. So, you know, if I'm listing out all of the areas where we can make improvements, and part of that is increasing production throughput, that's where the buy-in will come from the people making the financial decisions. They're making decisions based on my spend. What am I going to get for my return on my investment? So if I'm looking at adding features because I think they're nice and they're cool, they're probably not going to fly. But if I'm making the decisions, that is, I'm going to produce this much more parts, and I'm going to create this much more value for the company, then the opportunities will come, because now you're increasing the value that the actual process is producing. And part of that is to take that data. Like, the one thing that I didn't really talk a lot about is taking that data and how do I use that to market my product? Because if I'm producing a higher quality product and I'm creating something that's better than my competitors, can the salespeople utilize this to actually sell that product to more people, so increasing my market share?
I actually have a question that I'd like to ask. Is there a list of standard value questions to be answered to build a return on investment case?
Well, I don't know there's a standard, because we're going to be talking today with people in all kinds of industries, from process through, you know, let's call it assembly or digital manufacturing. But I think the thing is to look at your process and everything that touches that process or has an impact on it. And it really needs to go into a database, and then you need to look at it and go, can I make an improvement here? What can I do that's going to influence this in a positive way? And I would not be afraid to look at what's going to influence it in a negative way, because those are some of the traps that we, by not paying attention to, we get steered down there, or we fall into those traps. So part of analyzing this data is to make sure that you're setting a proper course for your company to stay efficient over the time.
Thank you very much, Steve. Let's give it one more minute, see if we have any more questions that come in.
You know, I just, you know, we got a minute here. We're in the process at Innovative of developing a standardized product, but part of that development is a whole data collection system that we're developing with that will become part of a standard package or standard offering on our custom machinery as well. So I just thought.
Okay, we have a question that came in. What steps innovative automation take to reduce production downtimes?
So part of what we're doing when we're manufacturing machinery is we're looking at possible wear points. We're looking at you know, possible areas that you know, are critical to the production, and how we deal with those is we typically will prototype that. So we have equipment in house that's, you know, we utilize, you know, welding equipment, robots and presses and all kinds of different things here. which we will take and those, let's call them tougher processes, we will prototype and do some light testing on them before we actually build them into our custom machinery.
Another question that's come in. Do you have any comments on the role of data in additive manufacturing industry?
Is that predictive?
Additive manufacturing industry. Sorry about that.
Yeah, okay. Well, I think, you know, there's a great example of where I can make adjustments in process if I'm doing additive manufacturing, because it's not like I'm taking a hard stamp product and I'm introducing it. I'm actually making the product. So there's an opportunity when I'm actually building the product to make adjustments to that product as required on the fly and let the machinery make that decision.
Okay, if there's no more questions, I would, that concludes Steve's presentations. Thank you once again, Steve. We will now have a networking/trade show break. During the break, don't forget to visit the exhibit hall where some of our exhibitors will be doing presentations in their booths, as well as answering any and all questions you may have. Or go to the networking tab and chat with industry colleagues. Be sure to come back at 11:30 for the MRO and DE stream sessions. Thank you once again, Steve.